We can talk about different levels of measurement and how they contribute to the way that we might want to symbolize a map. So any sort of level of measurement is going to be tied to the type of attribute that we have in our attribute table. And using that attribute, we can symbolize features on a map in various ways. So what types of attributes or levels of measurements do we have? We have four different ones: nominal, ordinal, interval/ratio, and cyclical. And we'll go through each of these now. Nominal just means that a point on the map has something associated with a name. So an airport, we might put on an airport symbol such as that, just to indicate that that's what that point on the map is. Or a mine, we might put on a symbol like those two crossed picks. Also, we do tend to label nominal symbols because each one of those has a name, so it might depend, the airport name or the town might be specific to that. But in all of these cases, we just put a symbol on a map based on a nominal attribute. With ordinal, there's some sort of ordering of the feature that we're putting on the map. So with the example for airports, it doesn't necessarily mean one airport has a larger volume of people flying through it or anything else. It just means in this case that one is regional and probably more likely serving a region, one is national, and one has international flights. The international flights might just be over the Canadian border over a very short distance, but because more paperwork and checking might be involved, it might be worth signifying that in a different way on the map. So we can put these different symbols on a map. Other times they may have related to numbers in the past, like for oil well production where there's high, medium, and low. But they've just been put into categories now, and there's no numbers associated with those values that we're mapping. And we can see what's happening here with our symbols. When for the higher order things, we get thicker lines, we get darker symbols, like the soil quality here is the darkest color for good, or the cost of living is the brightest red for high. And then as we go down in order, we get into lighter colors, thinner lines, maybe even dashed lines, or smaller symbols, maybe symbols without color. So we're using that ordinal attribute in order to help us symbolize the data that we're putting on a map. The same is true with interval and ratio. So in this example here, there's some sort of numeric value associated with this. So in this case here, for example, the precipitation, as we go up in precipitation, it gets wetter and wetter. And to symbolize something watery, we put on a darker blue color. Our population density might go from low to high here, and we get into here it's a change in hue that's illustrating that. Or the symbol itself might just get bigger, as in this populated place example here, based now on numbers instead of order. We're not saying this is high population density or medium. We're just assigning the different numbers to different size symbols and putting that on the map. So what is the difference between interval and ratio? For interval things that we put on a map, there is no meaningful zero value. So for example, temperature is an example of interval because although we have a zero, and it is in the Celsius scale, at least where water freezes, it doesn't have a meaningful value to say that it was 50 degrees today, and if the next day is 100 degrees, it's not very meaningful to say it's twice as hot because it's probably more than twice that hot. That's how it feels to people. But so interval is just something where the interval is defined, like a change in degrees Fahrenheit or Celsius, but the absolute zero is not really defined for the Celsius or Fahrenheit scale. Ratio is different. Ratio is where we have a definite zero that we all agree to. So a good example of that would be population density. If 0 people live in an area, we would say the population density is 0. No one lives there. If 100 people live in one area and 200 people live in another area that's the same size, it is meaningful to say that the population is twice as crowded or there are twice as many people per unit area in the second place as opposed to the first. We also have a cyclic level of measurement, and in order to make a cyclic measurement, we have to have some sort of cyclic scale. And of course, with mapping, the most common cyclic scale is the directions of the compass, the ordinal directions. So, and that can vary if we're measuring the direction of something, the aspect direction, from 0 to 360. One thing to keep in mind with this, even though this is a numeric value, it doesn't really have any magnitude associated with it. We can't really say that something 90 degrees away is half as big as something 180 degrees away. It's just the compass direction. That also means we can't apply mathematical functions. Like we can't say that if one bearing is 350 and another bearing is 10, we can't take the average of that and have a meaningful number. But the nice thing about these things is they're very easy to symbolize with the GIS because we can just point things in the right map direction and then put them on our map. So things that are measured in a compass direction are easy to do that way. Time is also a cyclical variable. We can put that on a map, although that typically requires some sort of more complex symbol. And we can also take a bunch of different attributes, put them around in a circle, and just make those attributes kind of stick out more in the direction that are more prominent in order to give someone an idea of how a lot of data would look on a map. So we can use these things called glyphs, which are chart-like symbols whose shape will show variations in more than one value. So once again, the compass direction is easy, right? Each of these arrows is just pointing in the direction of the steepest downward slope. And seeing all this together, we get an idea of what this mountain might look like. This shows one of those more complex examples. This shows subway ridership in Brooklyn. And each time around the circle, as we can see down here, is 1 week. And then it keeps building up. So week after week after week, we're moving up through this thing here. And this is showing a year's worth of data. So it's showing when ridership is high, what time during the day each day ridership is high, when it is low down in these valleys here, and then what time of year also. We can see this is, it goes from summer to summer. So this is a winter time when ridership is lower. And we're able to see all these patterns in kind of a complicated sort of three-dimensional symbol that we're putting on a map in this case. And this would be an example of those glyphs. So for these glyphs, each direction here, each one of these little pieces of pie might represent a different variable. And in this case here, all of these variables here would be high, but all of the variables down in this direction would be low. But in other places, all the variables down in that direction are high, and the ones up here are low. So by looking at the shape of these glyphs, which is using a cyclic pattern to represent a number of different attributes on one map, we're able to see how things fit together and see what's similar to other things and what is dissimilar. For example, this one and this one here.